A particle moves so that its velocity is v is t squared minus 9t minus 36 for t greater than or equal to 0. We want the initial velocity, so v of 0 is going to be 0, take away 36 meters per second. The time when the velocity is negative 26 meters per second. So t squared minus 9t minus 36, we want when that's equal to negative 26. So t squared minus 9t take away 10 is equal to 0. So t and t, if we put 10 and 1, it's going to be negative 10 or plus 1. So t equals 10 seconds, or t equals negative 1 seconds. And of course we know that that can't be true. So that one's no good to us, and this is our answer. When the particle is stationary, so that's t squared minus 9t minus 36 is equal to 0. So we can factorize this one. So t and t, 12 and 3, make that negative and that positive, so we get t equals 12 seconds, or t equals negative 3 seconds, and of course that one's no good to us, so it must just be at this time here. However, we can make use of that for finding the greatest speed in the first 6 seconds. We think about this parabola. So it's going to be that shape because of the t squared having a positive coefficient. And at 0, we know that it's negative 36. So it's going to be something like this. The axes are going to be there. We want to know the speed down here. Now, because we know that's at negative 3, I know this part of the curve doesn't actually exist because t is greater than or equal to 0, and this one's at 12, then halfway between those two is negative 3 add 12, which is 9 divided by 2, which is 4.5, and that's where we'll find this minimum. But of course, that's going to be the greatest speed. And 6 is here, and the only part of the curve we have is this, and this is where it's going the fastest. So it's going to be v of 4.5. So that's 4.5 squared. Take away 9 times 4.5. Take away 36. So we just need to calculate that. So we've got 4.5 squared. Take away 9 times 4.5. Take away 36, which is negative 56.25. And therefore the max speed is 56.25 meters per second.